So if I gave you something that was krypton 5s2, what period is that in? Fingers. Vote with your fingers. Krypton 5s2. 5. How can you tell? Well, you can do that. You can say, oh, well, it's the row below krypton. But you can also say, what's the highest main occupied energy level? 5. Which tells us it's in the 5th period. So highest main occupied energy level is always the same as the period. Okay. Groups. So yeah, groups. And you know what? A 10th grade physical science student about 8 years ago gave me this one. Gravity pulls things down. Groups go down because groups in gravity start with G. It works if you get them confused. Okay. Groups. Oh, looking at a periodic table. So as we travel this way across a period, what happens to the atomic radius? You have 2 choices. Well, 3, I guess. Gets bigger, stays the same, or gets smaller. Okay? How many of you vote smaller? How many of you vote bigger? How many of you are too chicken to commit to a position? Aha. Get smaller. Why? What are we adding as we go from lithium to beryllium to boron to carbon to nitrogen, blah, blah, blah? We're adding more electrons, and where are we adding them? In the outer shell. So we're not adding any more shells. We're not adding any more layers between the nucleus and those outer electrons, but we are adding more electrons. So now we have more stuff, in essence, to get a grip on and to pull it in tighter. So as you go that direction, the atomic radius generally tends to contract. What if we go this way, down a group? Gets bigger, why? You're adding layers. Yeah, you're adding you're adding energy levels between the nucleus and those outer electrons, so the whole thing is getting fluffier. If we think about the marble in the center of a room's worth of cotton candy, we're adding cotton candy to the outside. Okay. Resume. Okay. So we had molecular versus ionic compounds and pure elements, etc. What about molecular and empirical formulas? Do you remember those? If I have C4H10, is that a molecular or empirical formula? C2H5. Okay, so this is a molecular formula. What would the empirical formula be for this compound? C2H5. That's the empirical. It's the simplest ratio. Okay. Could I have multiple molecular formulas with the same empirical? Yep. So I could have C6H15. I could have C8H20. These are all molecular formulas, and they all have the same empirical formula. Okay, because the empirical just tells us the ratio of elements in a compound. Okay. What does each of those mean? Aqueous solution. What's an aqueous solution? Something that's dissolved in water. Acids are aqueous solutions, but not all aqueous solutions are acids. Salt water is an aqueous solution. Okay, generalized reaction types. What kind of reaction is that? Decomposition. And the key is, it's only got one reactant. Decomposition reactions only have one reactant. It's breaking apart into simpler things, either simpler compounds or into the actual element that it's made from. What about, this is a generalized equation type, or reaction type. What is that one? Single replacement, that's the heartbreaker. Oops. What's that one? Double replacement. Not heartbreaking, but possibly a little bit awkward. What about that one? Synthesis. Yep. Okay, if I tell you that I have 4 moles of this and 7 moles of oxygen, which one of those things is going to control how much product you can make? Which one of those things is going to control how far the reaction runs, how much product you manufacture? Which one's the limiting? Okay, if we have 4 moles of ethane, natural gas, it would take 14 moles of oxygen to burn that all up. We only have 7 moles of oxygen. So, yeah, you were flipping it. That's okay. So this would be the limiting. That would control how much we could produce. Because we only have 7 moles of that. We can only, the most of the ethane we could burn would be 2 moles. We can't burn any more than 2 moles of ethane. Okay. Okay. Now let's do just a little bit of Lewis structure practice. We'll just do 1 or 2. So if I give you, well, we'll start off with something nice and easy, H2O. So how many valence electrons do they have, how many octet, and how many are they going to share? So valence, how many valence electrons does hydrogen have? 1. So we have 1 times 2. Oxygen has how many valence? 6. It would like 8, but it only has 6. So we have 8 valence electrons between all of them. How many would everybody like for their octet? Hydrogen wants 2. 2 times 2. Oxygen wants 8. So we have 4 plus 8. We have 12 octet electrons. 12 that they want minus 8 that they have. They're sharing 4. How many bonds is that? 2 bonds. Okay. How many unshared do they have? So they have 8, and they're sharing 4 of those. 4. They have 8 valence electrons. 4 of those valence electrons are being shared. So there are 4 valence electrons that are unshared. We'll do just 2 more. CH4 methane. So, valence, octet, shared, carbon, hydrogen. So how many valence electrons does carbon have? 4. How many does hydrogen have? 1. So 1 times 4. So we have 8 valence. For octet, how many would carbon like to have? 8. If carbon got everything on its Christmas list, carbon would have 8 valence electrons under the tree. Hydrogen would like to have 2. Hydrogen has modest goals. 16 octet. 16 that they would like versus the 8 that they have. They are sharing 8 electrons. How many are unshared? They have 8, they're sharing 8. None. So carbon, hydrogen, 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 hydrogen. There it is. That's methane. That's cow fart. Okay, let's do an ion. NH4 1 plus. So valence, octet, shared. How many does nitrogen have? 5. Oops, I didn't write nitrogen. Nitrogen, 5. Hydrogen, we said, has 1 times 4, so we have 9. Now here's the challenge. We have a +1. So you have lost 1 electron. Remember, sodium calls the police because somebody's breaking into sodium's house, and sodium says, "You've got to come quick, I've been shot, I've lost an electron." And the police say, "Are you sure?" And sodium says, "Yeah, I'm positive." You can try to maintain that straight face, Kaylee. I know you find this uproariously funny. So, because of the +1, we're subtracting 1 electron. So we have 8 valence. For octet, nitrogen wants 8, hydrogen wants 2, 16. How many are they sharing? 8. So once again, that's 4 bonds. Couldn't be easier. 1, 2, 3, 4. And we put the brackets and the 1 plus because it's an ion. You have to do that. Okay, that's all I've got. I mean, your SLO is 65 multiple choice questions and a couple of short answer kind of things. It won't take you that long. Just do your best. And now you have time to work on the mineral sheets and on your outlines.